Hi, in today's lesson we're going to be talking about binomial distributions and doing some examples with binomial distributions. Let's now talk about the binomial distribution. What is a binomial distribution? Well, a binomial distribution involves something called Bernoulli trials. What is a Bernoulli trial? It's any experiment consisting of repeated trials where each trial has two and only two mutually exclusive. Remember, that means one or the other. They can't be at the same time. So we have two mutually exclusive possible outcomes. Either success, here's a key word, or failure. In a Bernoulli trial, we're talking about a binomial distribution, we can either have success or failure. Often, success is denoted P and failure is denoted Q. Continue on with our binomial distribution, which involves Bernoulli trials. Success or failure. Two mutually exclusive events can occur here. Success or failure. They're mutually exclusive. Well, the probability of success is P, that's small p, and the probability of failure is Q, small q. Well, if there's only two outcomes, the total probability must be 1. So P plus Q is equal to 1. Subtract P from each side. Therefore, Q is equal to 1 minus P. Let's now talk about the properties of a binomial experiment. Number one, you have a fixed number of trials. We know how many times we're going to do the Bernoulli experiment. N number of trials. N represents how many times we're going to do this success or failure experiment. On each trial, only two possible outcomes exist. Success, which we denote as P, and failure, which we denote as Q. On each trial is identical. We do the same thing each time and independent. The outcome of one trial does not influence the outcome of a second or third or fifth or 100th trial. And our fourth property is that on each trial, the P, the probability of success, is always the same. It doesn't change from trial to trial. And Q, the probability of failure, is always the same. And don't forget that Q plus P equals 1, so that Q equals 1 minus P. That's our relationship. What are some possibilities for Bernoulli trials? Let's think about flipping a coin. If we say that if it's a head, it's success, tail would be failure. Let's talk about picking a card from a deck. We could define getting a heart as a success. So we have 13 out of 52 possibilities or probability of getting a heart. Well, the failure would be anything but a heart. Well, there's 39 other cards, so it's 39 out of 52. We have to define each trial as something we call success and something we call failure. If I'm flipping a die, if I roll a 5, that's success. Well, then I have 1 out of 6 chance of success and 5 out of 6 chances to have not 5, which is defined as failure. That's how we can think of these Bernoulli trials or binomial experiments. We continue on talking about the binomial distribution, and here is what you really need to know. Once the parameters that we just talked about, 1 through 4, have been met, and we determine we have a binomial distribution, then the probability that our discrete random variable, capital X, is equal to some x is nx. Well, what does this nx mean? It means n combination x, where n is the number of trials we're doing, and x is the number of successes in n trials. So if I do 20 flips of a coin and I want 10, where I define heads as success, 20C10 means I do 20 flips of a coin and I want the probability that we get exactly 10 heads. Nx is the same as NCX. P, notice that the x here, whatever the number of successes we want, goes as the exponent of our probability of success. And Q here is our probability of failure, gets n minus x as the exponent. Well, NCX becomes NCX and P stays P to the x. Q, we saw before that if P plus Q equals 1, then Q is equal to 1 minus P. That's why I can substitute 1 minus P there to get this final formula. Although I often use this, NCX, P to the x. That's what I remember. I say, well, whatever's here is got to go there, and then whatever's left over, n minus x, goes on top as the exponent of the q. So this is the one I would remember and recognize that q is simply 1 minus p. Let's see how this formula works right now. When we're talking about the binomial distribution, you'll often see something like this. This means x is distributed binomial. When we're talking about the binomial distribution, you'll often see something like this. X is distributed binomially with the parameters n and p. That's the way they'll give it to you, just two numbers, one then comma the other. You have to remember that the first one is n, which means that's the number of trials, and the second one is small p, which is the probability of success. Well, the b means we're distributed binomially. Well, you remember your formula is going to be nx or ncx, and then it's going to be p to the x, q to the n minus x, which is really ncx, p to the x, 1 minus p to the n minus x. So what we really have here, if we're given n and p, the number of trials and the probability of success, the only thing we're missing is x, which is important, but it's the extra bit of information that they'll give us telling us how many successes we want in our fixed number of trials. Now we're ready.